We're going to solve some one-step equations first. So in order to solve them, you first have to identify what type of equation you're looking at. So in the first example, you're looking at x plus 3 equals 7. And I know a lot of us can figure out what x is just by kind of guessing and checking or figuring it out. You need to be able to show work because it's going to be really important when the equations start to get more difficult. So because this is an addition equation, you're going to do the inverse operation. And the inverse operation of addition is subtraction. Your goal is to get x by itself. So what's being done to x right now is 3 is being added to x. So you're going to do the inverse operation of plus 3, which is minus 3, and you're going to do that to both sides of the equation. What you should see right here is plus 3 minus 3 is a 0 pair, so it goes away. And when I do 7 minus 3, I get 4, so x is 4. And I could substitute into the original equation the answer of 4 to see if the left side and the right side are equal. And because the left side and right side are equal, we know that the answer is x equals 4. In the second equation, x minus 4 equals 10. 4 is being subtracted from x, so it's a subtraction problem. To do the inverse operation, we're going to add 4. Again, minus 4 plus 4, 0 pair, which means it's 0. What I do to one side, I do to the other. On the left side, I'm left with x. On the right side, 10 plus 4 is 14. I can make sure that's correct by substituting 14 for x and doing 14 minus 4, which is 10, and 10 equals 10, so I know that my answer is correct. Third problem is a multiplication problem because when a number and a variable are together, it means multiplication. So the inverse operation is division, and what I do to one side, I have to do to the other. So when I divide both sides by 2, I get x equals 7. And if I substitute 7 in for x, I get that 14 equals 14, and I know that my answer of 7 is correct. For this final equation, I'm going to go ahead and rewrite it as x over 4 equals 12, so it's just a one-step equation. And if I look, x over 4 is division, so I'm going to do the opposite, which is multiplication, and I'm going to multiply both sides by 4. 4 and 4 cancel out, and I'm left with x equals 48. And if I do the substitute in, 48 divided by 4 is 12, so I know that x does equal 48. So here are two-step equations. Our goal is to do in reverse PEMDAS. So in PEMDAS, we would multiply and divide before we would add and subtract, and when we're undoing, we're going to go from adding and subtracting and then multiplying and dividing. So if we look at 2x plus 8 equals 16, our goal is to isolate the variable of x. Well, right now, 2 is being multiplied by x and 8 is being added to x. So our first job is going to be to undo the addition or subtraction because we're going to be going reverse PEMDAS. It's a positive 8, so I'm going to subtract 8 from both sides. When I subtract 8, I create a 0 pair, which means I can get rid of it on the left side, and then 16 minus 8 is 8 on the right side. Now I'm left with another one-step equation. 2 times x equals 8. Multiplication, so I divide. And I'm left with x equals 4. Again, if I substitute 4 in for x, and I check my work, I get 2 times 4 is 8, and 8 plus 8 is 16, and I know that 16 does equal 16, so I know for a fact that x equals 4 is correct. Okay, now 9 is being subtracted from x, negative 3 is being multiplied by x, so I'm going to do the inverse operation of minus 9, which is plus 9, and I get negative 3x equals 21. Now I'm going to divide both sides by negative 3, which kind of gives me a little integer twist. We're getting even better at integers. Negative 3 and negative 3 cancel out because negative 3 divided by negative 3 is 1, and 1 times x is x. I'm left with x equals negative 7 because a positive 21 divided by a negative 3 is a negative 7. If I substitute it in, negative 3 times negative 7 is positive 21, and positive 21 minus 9 is 12. So I get 21 minus 9 equals 12, which is correct. It's an addition problem, so I'm going to subtract, create a 0 pair. I have a number divided by 3 equals 3. Divide it by, so I'm going to, inverse operation is multiplication. I'm going to multiply both sides by 3. I'm going to get x equals 9. If I substitute 9 back in, 9 divided by 3 is 3, plus 6 is 9, and I know that 9 is my correct answer. I'm going to add 10 to both sides. Because it's subtraction, I create a 0 pair. I get x divided by 5 equals, and I get negative. And I get -5 plus 10. -5 plus 10, the signs are different, so I subtract and take the sign of the bigger number. So 10 minus 5 is 5, and the bigger number is 10, so the 5 is positive. And then I go ahead and multiply both sides by 5, and I get x equals 25. I multiply by 5 because this is a division problem, so I do the inverse, and 5 divided by 5 is 1, so I can cancel them out because 1 times x is x. Again, if I plug 25 in to x, 25 divided by 5 is 5, and 5 minus 10 is -5. So I know that x equals 25 is my answer. So here are some equations that may look different, but if you understand the basic principle of isolating the variable, I'm hoping that you'll catch on. So in this case, the 3 comes first. We're used to maybe seeing the variable come first. That's fine. The 3 is positive, so we're going to subtract. Remember, because the sign comes in front of the number. So really, if there's no sign, it's positive. What I do to one side, I do to the other. I bring down the entire -4x, and that equals positive 16. I divide by -4, and I get x equals -4. Now it's -10, so I'm going to add 10 to both sides. I bring down the positive 2x, it equals 22. I divide both sides by 2, and I get x equals positive 11. Again, I could go through and check each of these to make sure that they're correct. I'm going to subtract 2 from both sides because that's a positive 2, because this negative sign is attached to the x. This goes away. I bring down the whole -x over 5 equals 10. And I remember that -x over 5 can equal x over -5, or it could equal negative in the middle. So if I can pass this negative sign to the 5, and I multiply both sides by -5, I get x equals -50. Again, if I plug it back in, 2 minus -50 divided by 5, so -50 divided by 5 is -10. 2 minus -10 is 2 plus 10 is 12. X equals -50. -3, I'm going to add 3 to both sides. I get x over 4 equals 15. I multiply both sides by 4, and I get x equals 60. Again, if I plug 60 in for x, I get -3 plus 60 divided by 4. 60 divided by 4 is 15. -3 plus 15 does equal 12. Last slide. This slide seems to be the one that people miss a lot because they see a negative sign in front of x and they're really not quite sure what to do. But we've seen negative signs in front of parentheses, and I've said put a 1. Negative sign in front of x, put a 1. So you're going to solve it just like you solved any of the other ones, positive 3. So you're going to subtract 3 from both sides. 0 pair. You bring down the -1x equals 9. You divide both sides by -1, and you get x equals -9. If there's a negative x, it means it's -1 times x. You can't ignore that. -5, you're going to add 5 to both sides. Again, you have -x, which is the same as -1x, equals 20. You divide both sides by -1, and you get x equals -20. You can always plug back in. -5 minus -20 equals 15. -5 plus, keep change opposite, 20 equals 15. Signs are different, so you subtract. 15 equals 15. And now I know x is for sure -20. Positive 5, so I'm going to subtract 5 from both sides. -1x equals -10 minus 5. Keep change opposite. Signs are the same. I add and keep the sign. Divide both sides by -1. X equals positive 15. Again, 5 minus 15 equals -10. Keep change opposite. Yeah, 5 plus -15 does equal -10. If I wanted to do the last one, I go ahead and add 4 to both sides. -1x equals -12 plus 4. Notice that I'm rewriting the vertical problem, the problem that's above each other, next to each other, because we are more familiar with negative 12 plus 4 written horizontally than we are with it vertically, because we say the signs are different, so we subtract and we keep the sign of the bigger number. And then you divide both sides by negative 1 to isolate x, and x equals 8. So your job is to flip over your video worksheet and solve these 6 problems. There is going to be no solution in this video because we are going to discuss these 6 problems tomorrow, and I want you to come in with your answers so that we can figure out how your solutions are the same or different than your classmates.